So in the previous videos, we talked about what are modules and how to create modules and publish modules to Terraform registry, right?
Yes.
Okay, so in this video, we'll talk about how to create AWS VPC using module. Okay, using VPC module. In the next video, we'll talk about how to create VPC from scratch without using module. Okay, so there we'll use individual resources like VPC, subnet, route table associations, Elastic IP. We'll use individual modules to create complete VPC. Okay.
Yeah.
But here we will talk about only how to use VPC module. Okay.
Yeah.
Got it. So now what we'll do is we'll see all these topics. So we'll start with very basic, like what is CIDR and what is subnet. Okay, because these are needed to understand what do you say, VPCs, because we use these terms in VPCs a lot. And then we'll talk about what is a VPC, what are internet and NAT gateways. Okay. And then public versus private subnets, route tables. Okay. And then we'll talk about resource map. Resource map is not any object in VPC. It is just a map of all the resources that are part of a VPC. Okay, so we'll see that in the console. Okay, and then finally we'll understand about the difference between security groups and network access control list, NACLs or NACLs. Got it?
Yeah. Yeah.
Okay. So what is CIDR? So CIDR stands for classless interdomain routing. Okay. So it is a method of specifying the IP addresses and their range. Okay. So basically we use the CIDR notation to specify how many IP addresses we need. Okay. So this is called classless because it won't follow any class based IP addressing. Like we have class A, B, C, D, right? Okay.
Yeah.
So if you see various classes, you'll understand, but this doesn't comes under any class. We can use any sort of ranges with any sort of prefix. Okay. If you just browse internet for all the IP classes, okay. So these are very limited, right? So we have class A, class B, class C, and class D. Okay. And also the mask, subnet mask is also fixed. Like the slash notation is fixed. Okay, so let me show you an example. Okay, so they have fixed number of IP address ranges. Okay, if you see here, class A has subnet range, subnet mask of slash how much? Slash 8.
Yeah.
Okay, then slash 16, then
16.
slash 24, like that. Okay. Subnet mask, the value you can see here 8, 16, 24. Okay, like that. Okay, so they have fixed number of IP addresses. So if you go to IP subnet IP calculators, then you will understand. So there are a lot of IP addresses. Okay, let's say I only need some probably like 64 IP addresses. Then I can't use a standard class IP addresses, right? IP classes, right? Instead, I'll go for classless interdomain routing where I can select my own subnet mask. So basically, what is the subnet mask? So if you look at this example, okay, so 192.168 1.0. So everything can be represented in the form of octet, right? Okay.
Yeah.
Okay, so the maximum number I'm writing. Okay. So here, this is 8-bit, 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 and 8-bit. Got it. Okay,
Yeah.
so in order to break the network, we need to break it into the network and also into the host, which means the total IP addresses or the systems that can be part of that network. Okay, if it is slash 24, which means 24 bits. See, these are 8 bits, 8 bits, 8 bits, 8 bits. 24 bits means first 24 bit is the network, which means you cannot touch anything in the first 24 bits. So last 8 bits are only used for. Okay.
Host. Yeah.
Got it.
Yeah.
The last 8 bits, which means they start from 0 right to 255. So of course, first and last we will not use it. Okay. So the remaining IP address, but I may not require those many IP addresses. Okay. I am creating a small network in that I only need 64. Okay, then how do I restrict that IP address range? Okay, so using subnet mask. Okay, which means, so this, whatever this mask is not fixed, you can vary it. That's why it is called classless. Okay, because we have variable length subnet masks. Got it? So this is very important feature in VPC, because when you're creating VPCs, we'll create subnet. So we can define how many IP address that can be part of that subnet, right? Subnet sider. Okay.
Yeah.
And what is a subnet? It is a smaller part of a large network. Okay. If you have a big network, I can break it into multiple small networks. Okay. So why we use these small pieces of networks to restrict the communication? Okay. So this network probably I'll use to deploy web servers. This network or subnet I'll use to deploy databases, let's say. And subnet to subnet, usually there won't be any communication. Okay.
Yeah.
Unless you have a router to route the traffic. That's the reason why we go for subnets. Okay. Now let's talk about VPC. That is, AWS VPC. So we know what is AWS VPC, right?
Yeah.
Okay. It is a private isolated network within your AWS cloud. Okay. So this is basically a foundation of network infrastructure within AWS, and it plays a very important role in structuring and securing your whole cloud environment. Okay. So within VPCs, obviously you can create multiple subnets, and within each subnet, you can run your own instances. Like it can be EC2 instances or RDS instances. Got it? So if you see, this is a reason, and I have a VPC in a region. Okay. And one more thing. So a VPC can only exist within a region. Okay. A VPC is restricted to a region. And within a VPC, within a region, a VPC can span across multiple availability zones. Okay. If a region has 3 availability zones, whole VPC can span across the 3 availability zones. That's the reason why you can see this VPC green color part. It is available across the availability zones. Got it?
Yeah.
Understood? So this is a reason. So VPC never leaves a region. Okay. And every AWS account comes with a default VPC. Okay.
Yeah.
Understood? And if you don't mention any VPC when launching instances, all the instances will be launched in the default VPC, and automatically all the instances get a public IP address. Okay. That's the reason why we are able to SSH into these instances, because they have public IP address. Okay.
Yeah.
Understood? And also they'll have access to the internet from that VPC. Okay. And if you take any VPC, default VPC of a particular AWS region, they will have the CIDR block of this. Okay. 170.31.0.0/16. This is not for any subnet. This is for the entire VPC. Okay.
Yeah.
Got it?
So
And
subnet is like, from this network we can.
correct. You can create.
Yeah.
Okay.
Yeah.
So you can create multiple small subnets, and then you can have subnet related CIDR. Okay. And every region will have a default VPC, and every availability zone within that region, okay, has one subnet. Okay. If there are 6 AZs in a region, all 6 AZs will have one subnet. Okay. Okay. And each subnet will have /20 as the CIDR.
Okay.
Got it? Whole it is 16. Okay. See, whole it is 16 means, so these two are blocked. Okay. Which means only these two should be used to what? To create a VPC and break it into all subnet. So within these two, /20 will be used. Okay. What is /20? Okay. 16 is already used, and then rest 4 are already used, which means here you will have how many? 4 bits dot 8 bits. Got it?
Yeah.
Like that. Okay. Subnets are directly associated with the availability zones. Okay. When you create a subnet, okay, so every subnet should be within an AZ. Remember, okay? It should be within an AZ, whatever subnet you create. Okay, so that is about VPC. So if you look at the key features of VPC, so one is isolation. Okay, so you can put your web servers in the public subnet, databases in the private subnet. Okay, so this ensures that resources are secure and they only communicate within that VPC. Okay, so no other instances can be can access these resources within the VPC. Okay, and also IP address ranges, as we already discussed, right? So every VPC comes with a CIDR. Okay, and each subnet can be separately configured. Got it? And coming to the subnets, you can create multiple subnets. Okay, and each subnet can be associated with a availability zone. Okay, so why it is done? For redundancy and fault tolerance.
Okay.
Okay, and then internet gateway and NAT gateway, I'll explain about what is this internet gateway and NAT gateway, okay, in some time. Okay, and why these are required. Okay, so basically, okay, let me explain this diagram. So if you see this whole diagram, okay, so we have a region. Okay, so inside this region we have a VPC. Okay, so this is VPC. So inside the VPCs, okay, I mean within a region we have availability zones, right? So let's say these are availability zones. Okay, as we already discussed, a subnet has to be associated with a availability zone. Okay, AZs will have subnets. Got it? It can be public and private, both. One availability zone, there are two subnets in it. Another availability zone, there are two subnets in it. Okay.
Okay.
Got it? Now, within subnet, I have some instances. It can be RDS, it can be a basic EC2 instances. Okay, so these are private subnet. Okay, within public subnet, actually I can deploy something like web servers and all, but I don't have anything. I have an application load balancer. Okay, understood. Deployed in public subnet. Why application load balancer is deployed in public subnet? Because this load balancer has to load balance the request, right, to the instances in the private. But why it is in public subnet is because this application load balancer has to be accessible from internet.
Okay.
Okay.
Yeah.
Which means this application load balancer should have public IP. Okay. Anything that you deploy in public subnet will have an IP, public IP. Okay. So why these are in private subnet is because I don't want direct access to these instances. Because anything that is deployed in public subnet will not have any public IP. Without public IP, people cannot access it. That's the reason why you will not have any public IP assigned for the instances deployed in private subnet. Okay. Now there comes two questions. One, okay, see this, let's assume this is an EC2 instance. Okay, it needs to download, let's say something from the internet. Okay, I'm not talking about reaching the internet. Okay, sorry, I'm talking about reaching the internet. Okay, let me draw again. So this instance, EC2 instance, which is there in the private subnet, has to go to the internet to download something. Okay, but by default, it will not go, right? Because there is no public IP.
Yeah.
Okay. Private subnet will not directly cannot access the internet. Okay. Then what should I do in this case? Okay. So before understanding that, we should understand about internet gateway. Okay. So what is this internet gateway is? Okay. So it allows both outbound and inbound internet connections. Okay. Got it?
Yeah.
Clear? It allows both ingress and egress, both. Okay. So one more thing you need to remember here is, so you cannot name a subnet as public or private. There is no name. Like, let's say if I name a subnet as public, it is not public. If I name something as private, it is not private. It is a subnet. But how a subnet becomes a public and how a subnet becomes a private is public subnet. Okay, which means it can have any number of instances, right, inside it.
Yeah.
It is a subnet. there is a CIDR range. Okay, let's assume there are 64 IP addresses, which means I can deploy 64 EC2 instances. Got it?
Yeah.
So how a subnet becomes public is if this subnet has a route table to the internet gateway, which means this public subnet, whatever instances you deploy, they can go out to the internet through internet gateway, because this public subnet is associated with a route table. That route table has entry to the internet gateway. Okay.
Yeah, got it.
Understood? So
Yeah.
if I associate this subnet with the routing table that has internet gateway, this also becomes public. Even if this subnet is associated with the route table that has a route to the internet gateway, then that also becomes public.
Yeah.
Okay. So what is that other advantage of internet gateway is you can also access the it also receives the traffic from internet.
Okay.
Okay. So that is one thing. That is how a subnet becomes public. Now the question is, this private subnets also needs internet access. Okay. They also want to access internet. Okay. But they don't want to be accessed from outside. They will access internet, but others cannot access them directly. Okay. Which means I cannot use internet gateway because it allows two-way traffic. There comes the NAT gateway. Okay. What is the use of this NAT gateway? It allows only outbound traffic, no incoming traffic. Okay.
Yeah.
Got it? Now, how a subnet becomes private is if this subnet has a route table that is pointing to the NAT gateway, then that subnet becomes a private subnet.
Okay.
Got it? So the public subnet has route table that is routing to internet gateway, it becomes public. Private subnet, if it is associated with a route table that has route to the NAT gateway, it becomes private. Okay, which means the instances inside this private subnet, they can talk to internet. Okay, but it will not allow any incoming traffic. Okay. Now there comes the other question. Why the NAT gateway is in the public subnet? Why can't I deploy NAT gateway here? Okay. So remember one thing, only the instances, okay, within the public subnet, they only get the internet access, right? That's why NAT gateway, since it also needs internet access, it should be deployed in the public subnet only. This is very important. Okay. Got it? Since anyways public subnet has route to the internet gateway, so it will go out. That's why NAT gateways are deployed in the public subnets, and application load balancer are also deployed in the public subnet because they also need access from the internet.
Okay.
Clear?
Yeah.
Okay. Understood? Now internet
so
gateway NAT.
How without even having a public IP, from then how we can able to log in? So even
How
though
we
if
will
it's in a
able
private, log in
Nice.
the SSH.
No, you won't able to SSH into the private instances.
Okay.
They don't have any public IP.
Okay.
Okay.
So if I have a requirement like I need to log into the machine,
then you should go for Bastion host. Okay, I'll talk about this in VPC part in AWS once we start. Okay, so where we deploy specific instances in public. Okay, okay, so we deploy instances in the public, and from here we will SSH. Okay, so user first will log in into this VM. From this VM, he will access the private VMs, private instances.
Okay, got it.
Okay.
Yeah.
So now VPC provides isolation. They have certain IP, CIDR, subnets, internet gateway, and NAT gateway. Always remember, NAT gateway should be deployed in the public subnet. Okay. Got it?
Yeah.
And then security groups and NACLs. Okay. So security groups and NACL provide security, to your subnet as well as the instances. We'll talk about this separately now. Okay. So VPC peering and VPN. Okay. So what is VPC peering? Okay. If you want to connect two different VPCs, we can connect through to VPC peering. And also you can connect from on-premise network to your VPC through VPNs. Okay. Direct connect. So what is this direct connect? So there is another service called AWS Direct Connect. Okay. So what is AWS Direct Connect? Okay. So AWS Direct Connect uses AWS high band network connections. Okay. To connect your data center to your AWS VPCs directly. Okay.
Okay.
So instead of going through the public internet, okay, which is sometimes it is slow and sometimes it is faster. Okay. So we will actually use high bandwidth
Correct.
networks of AWS to direct connect. Now we have route tables, route table associations. I'll talk about this. Okay. And VPC endpoint. So what is this VPC endpoint and what is this transit gateway? I don't have to explain now. What is VPC endpoint is, let's say you need access to the S3 bucket. Okay. So you have an instance in the you know in the private subnet. Okay. And it needs access through S3 bucket. Okay. S3 bucket is publicly accessible, right? Basically.
Yeah.
So instead of accessing S3 bucket through the internet, I mean talking to the internet and then talking to the S3. So what we can do is we can create a endpoint. We call it as VPC endpoint. So using that endpoint, you can directly talk to the S3 service, okay, without going through the internet. Okay. So these are all complex topics. We will see them later. And also transit gateway. Okay. So transit gateway simplifies your VPC to VPC architecture. Okay. So if you have, let's say, you know, two VPCs here, two VPCs here. So instead of creating structures like this, okay, like a VPC talking to one VPC. So, it is one-to-one map, right? So it has to
Yeah.
talk to this, it has to talk to, it has to talk to this, it has to talk. So instead of that, what we do is we can create an VPC transit gateway where all VPCs connect to the transit gateway. Okay. To simplify the VPC to VPC connections. Okay. Again, this is not required. Okay. Simply I'm explaining. Okay. As we already discussed, a public subnet is a subnet that has route to the internet
Internet
gateway.
gateway.
Okay, so that the traffic will flow out and it will also flow in. So okay, basically web servers, load balancers, or any service that needs access to the internet and also others needs to access those instances, you need to put them in the public subnet. Okay, coming to the private subnet, as we already discussed. Okay, private subnet. So private subnet is a subnet that doesn't have a route to the internet gateway. Okay. It has route to the NAT gateway, and through NAT gateway only they will go out. Okay. But inbound connections are not available. Okay. You cannot reach those instances through public internet just because they do not have any public IP addresses. Okay. So, but then where exactly the public IP will be used here? Okay. So I'm saying there is this private subnet. There is one EC2 instance here. I'm saying through NAT gateway, it can go out, but someone should have the public IP, right? To go out. Okay, who will
Yeah.
get the public IP? So your NAT gateway gets an elastic IP. Okay,
Okay.
got it.
Yeah.
So your NAT gateway gets an elastic IP. Okay, so usually you deploy in resources such as databases. Okay, inside the private subnet, right? To
Yeah.
isolate them. Okay, so in order to avoid accessing them from the public internet. Okay, now this is VPC resource map. Okay, so this VPC resource map will show you all the resources that are connected to this VPC. So if you have a VPC, you can see the CIDR range. Then you can see how many subnets that VPC have. Okay, got it. So it has 4 subnets, and then you can see the subnet CIDR also. We already discussed, right? So main VPC will have /16 as the subnet mask, and rest others will have /20. Okay. And then VPC. So these are subnets. So by looking at these subnets, you cannot, distinguish between public and private. Always remember here.
Okay.
Okay. So these are just subnets. If this subnet has a route table that points to the internet gateway. Okay. If you see this subnet and this subnet has a route table, which is just a routing. I'll show you. That routing is pointing to internet gateway. Then these becomes public. Okay.
But
And anything that doesn't have route table to the internet gateway, these are all private. Connecting them to the NAT gateway is a separate thing. If you need internet access, then you will connect to the NAT gateway. Apart from that, these are all private. Okay. So just don't think that they have to be connected to the NAT gateway. It is not like that. They are private if they are not connected to internet gateway.
Yeah.
Okay. Now see this example. So I have a public subnet. Okay. So this is the CIDR range. Okay. I can decide my own CIDR range. It is not only /20. That is for the default VPC. Okay. Then I have 3 different web servers that are part of public subnet. Okay. Now these instances require public internet access. Okay. So the public subnet has access to the internet gateway. So this is internet gateway. So how do you decide? Okay. If you look at the route table. Okay. So this route table is associated with the public subnet. Okay. So what does this routing table say is, so any traffic that is coming from this range, it is a local. I mean, so this instance, maybe it is trying to connect to this instance. It is a local traffic. There is no point in going to the internet. Okay. Anything that is not non-local, you go to internet gateway. Then internet gateway will route the traffic out. Got it?
Yeah.
Now coming to the private subnet. Okay. So again, there are some instances like database instances. Okay. So what this route table that is associated with this private subnet says is anything which is local, okay, the target is local, which means the traffic should not leave that subnet. Anything that is non-local, okay, should be pointed to the NAT gateway. And NAT gateway, as we already know, it should be in the
public
subnet. Got it?
Yeah.
So what is the route table association is? Okay, see, there is this route table. Okay, you need to connect to some subnet. Okay, this routing table has route to the internet gateway, which means if I take this route table and associate it with the subnet, then that subnet becomes public. Okay, this association is called route table association. That's it. Okay, if you take a table and then associate it with the subnet, then it is a route table association. That's it. Okay. Now coming to the security groups and NACLs. So this is again a very important interview question. Okay. So we all know what is a security group, right? So security group is operates at the instance level. So if I have an instance, okay, so I will have a security group around that instance that will, basically control inbound and outbound traffic. Got it. So every instance can have, an individual security group. Got it?
Yeah.
The security groups are basically operates at the instance level. Okay. And also these are stateful. So what is stateful is, so let's say I am actually, allowing the traffic from 80. Okay. So if I'm by default, it will also allow the outbound traffic for the same 80.
Yeah.
Okay. Let's say I am allowing the traffic from a specific IP address. Then return traffic is also allowed. Okay. Then what is NACL? Why NACLs are introduced? If you have security, see, if there is a private subnet that has 100 EC2 instances, okay, that 100 EC2 instances, I cannot have security groups associated with them, right? Instead, what I will do is, okay, I will associate NACL at this subnet level. Then all the instances that are part of that subnet will get these rules. Okay. Always remember, NACLs operate at the subnet level. Security groups operates at the instance level. Then what is the difference? Okay. See here, if you try to allow a traffic through NACL, okay, return traffic is not allowed until you explicitly mention that in the rules. So these are stateless. Okay. So if subnet has NACL and also security groups, both needs to be evaluated to decide whether a particular traffic has to be allowed or not. Okay, first NACLs and then next security groups. Got it? Yeah. Okay. Yeah. So that is the about VPCs. Okay. So if you want to know more about VPCs, okay, so Amazon's documentation is the best thing. Okay, you can go to AWS documentation and then VPC. So you can understand about VPCs, the CIDR range. Okay, the default VPCs. Okay, so what is the CIDR range of the default VPC? Okay, internet gateway, you can see. Okay, so this default VPC, it will have subnets per availability zone, and all are connected to the internet gateway. That's the reason why we get public IP addresses. Okay, you can see what is the route table. All of these subnets will have. Okay, I think all are public subnets. Okay, that's the reason why local traffic stays inside the VPC. Non-local traffic will be pointed to the internet gateway ID. Okay, now how do I find out all the default VPCs? So if you go to VPC service, okay, so there will be at least one VPC available in a region. So I'm in US East 1 region. If you click on the VPC, so this is the VPC. Default. So how do you know whether it is a default VPC or not? So if you select the details about the VPC, then it will show default VPC. You can see the CIDR. Okay, and then route table associated with this. Okay, now let's see I can open this route table and see. Otherwise, you can see this resource map. Okay, if you see this resource map, this is the default VPC. This default VPC has 6 subnets because we have 6 availability zones inside this region. Okay, got it? And all these 6 subnets are associated with the route table. That route table is pointing to the internet gateway. That's the reason why all the subnets become public subnet. So this is the route table. So when you associate a subnet with, when you associate a route table with a subnet, then that becomes the association. Okay. Now let's look at this route table. Okay. So let me open in a new tab, and also let me open this IGW internet gateway. Okay. So this is the route table. And if you look at the entries in the route table, it says anything within the VPC stays within the VPC. It won't go out. Anything that is non-local should reach this IGW. And then what is this internet gateway? So we all know that internet gateway will route the traffic outside. Yeah. Clear? So there is no NAT gateway, currently in our region, because we don't have, we did not create any NAT gateway. Okay, now VPCs are clear at least to some extent. Yeah. Okay. And then you can have CIDRs, all these things. Okay. Now let's look at how to create a VPC using VPC module. Okay. Yeah. So that is our main. Okay. So I already have that particular logic. Okay. So what I'll do is I'll simply create another folder. Okay. So I'll just say VPC. So what are the various things we can use here? So let me start with the main.tf. Okay, and then we also have to use the providers, right? So providers.tf. So inside the providers, so which provider? It will be AWS provider, right? So let me open Terraform registry and then browse providers, AWS provider. Okay, so let me use this provider. So configuration also we will do. So configuration is, so the region is, let's say US East 1. Okay. Got it? So our provider block is ready. Now let's go to main block. Okay. So inside the main block, we need to use the module, right? Let's go to modules and then click on VPC modules. Okay. So I'll refer both GitHub, okay, in a separate link, and also the examples from this. Okay. So blindly, let's copy this module. Okay. Got it? Yeah. And then source is this. Okay. I did not find the version. So how do I find the version? If you go to the right hand side, so here you'll have the version information. Okay. You can use. Okay. Now, see here, we have the name and we have the CIDR range. Okay. Yeah. So if I need a custom name and all those things, what I'll do? Okay. So these are the defaults, right? Okay. So first, let me, we can pass it through. Yeah. So let me first save this configuration and let's quickly do Terraform init to download that module first. Okay. Okay. So first let's download that module and also the provider. Okay, so we have inside .terraform we have the module downloaded and also the provider downloaded. Okay, so what we will do now, so we can directly use variables to set the VPC name and all those things, right? Okay, so let's do that. Let's inside of main, I mean here, so let's create variables dot tf. Okay, so let me open it in the other window. Okay, so what we will do now, okay, so we will try to create the variables, right? So first variable I create is reason, because I want to set the reason uh, from the variables. Okay, so it is US East 1. Okay, and then I'll go to the providers, and then I'll replace this reason with
That
var.reason. Reason. Okay, so this is done. Now another variable is so VPC name. Okay, so what will be the VPC underscore name? Okay, so default is, let's say, my custom VPC, something like this. And then here I'll replace it with variable. Okay, so var dot VPC name, and also cider. Okay, so variable VPC underscore cider. Okay, so I'm going to use the default one only. Okay, so default is, okay, this. Got it?
For this, you need to mention type, right? It's a number.
Sorry, var.vpc cider. So type
For this,
is not
yeah.
required because the default type is string, right? So these are all strings.
Okay, fine.
Okay, so
I
I
thought
don't
it's a
have to.
number.
No. Okay, and then we have availability zones. Okay, public subnets and private subnets, right? So I need to also use them as variable. Okay, but before that, what I'll do is, see, these availability zones might change, right? I don't know what are these available, because the reason I set it as US East 1. Okay, but I don't know what all availability zones I have. Okay, so for this, what I'll do is I'll take the help of Terraform AWS provider. I'll go to the documentation, and then I'll search for availability zones. Okay, so inside the data sources, what I have here is I have availability zones. Okay, so what is a data source? So it will allow you to fetch the data that is already there, right? So using this, okay, data block, I can find out all the availability zones of a region.
Okay.
Got it?
Yeah.
Understood?
Yeah, go.
Okay, so let me copy this. Okay, so this will fetch all the availability zones, and the reason is already set in the Terraform configuration. So let me output it. Okay, so output, let's say is this. Okay, and here the value, what I'll do, it is data dot availability zones. Okay, dot available dot. So what all things I need? I need the names of those availability zones, let's say. Okay. Then simply, okay, so let's do one thing first. I don't want to create, right? So let's comment out this module block. Okay. Otherwise it will be created, right? Now what we will do is, let's simply do Terraform apply auto approve. So this approach is required because we might have multiple availability zones, right? Okay. So let's say there are 6 availability zones, but I need to create only 3 subnets. Then I need to know how to restrict those availability zones. I cannot hard code them, right? Those data should be in the real time. Correct. The data should be fetched in the real time. Okay. You can see how many availability zones are there?
6.
There are 6 availability zones, but how many VPCs, how many subnets I'm trying to create? Okay. It is 6 subnets only, private 3 and public 3. Okay. Got it. So instead of hard coding them as an array, okay, just like how these guys did in the example. Okay, if you see the module example, they have hard coded it, but I will not hard code it. So what I'll do, I'll use it from the data block. Okay, let me delete the output. I don't want to do that again. Print it again. I'll take it from the data. Got it?
Yeah. Yeah.
And public and private subnets also, what I can do, I can move them, right? So this,
Yeah.
I will cut it. This is a private. Okay, so variable. Okay, so let me say private subnets, and the now this time the type is list of string.
Yeah.
Okay, and then the default value is, okay, so whatever is the default value, this one. Okay, and
Yeah.
again I'll create variable for public subnets, and again type and the default I will just copy paste from here, and the default value is this. Okay, getting?
Yeah.
Okay, and here it should be var dot private subnets and var dot public subnets. Okay, so here within the module, okay, so they actually have certain logic. If the availability zones are, let's say, 6, okay, so 3 public subnets and 3 private subnets will be created. Okay, let's say you have only 2 public subnets and 2 private subnets. Let's say I want only 4, but there are 6 availability zones, which means, even if they take 1 subnet per availability zone, 2 availability zones will be left out, right?
Correct. Correct.
Okay, so which means they will automatically choose. Otherwise, see, the result of this is 6. Okay, but
Yeah.
I need only 4. Then, so if I want to break that list, okay, let's say if there are 6 elements of the list, I want only 4. I can use slice list function in Terraform. Okay, so where if I use slice, and then if I pass the list and starting index and end index, then only those number of things will be used. Okay, so let me quickly show you how to do that. Okay, so let me use the output block again. Okay, output is ASIS. Okay, so value is data.availability zones.names. Okay, so it will print 6, right? Okay,
Yeah.
but what I'll do is I'll use slice function, pass this entire list, and then I'll say start from 0 and end at 4, which means 0, 1, 2, 3. Got it? And
Yeah.
then let's just comment out this module bug, otherwise it will be created. Okay, so let me run Terraform apply again. So what should be the response? It should only print 4 availability zones. Okay, so again you need to remember one thing here. If the availability zones are only 3, so this 0 to 4 again becomes invalid, which becomes this entire value becomes invalid. So it may result in error.
Yeah.
Got
Correct.
it? So only if you are sure that availability zones are more than your required number, then only you should go for this. Now see here, I got only first 4. Clear?
Yeah.
Okay, so this is how you use a slice function. Okay, so now let's uncomment this module block. Okay, so now ACS, public subnet, private subnets are all done. Okay, so now it's time for us to decide the internet and ad gateway. So enable VPN gateway. So which means internet gateway will be created. Okay, and then coming to the where is our browse module, VPC module. So how do you control the NAT gateway? Okay, so here NAT gateway, it is enabled. Okay, but by default, the NAT gateway is created for every subnet. Okay, if there are 6 subnets, so 6 NAT gates will be created. So I don't want that. I want only one NAT gateway. Okay, so if you want only one per subnet, you need to say single NAT gateway equal to false. Okay, otherwise, let's say I only need single NAT gateway. I don't want one in a subnet. Okay, if there are 6 subnets, there are 6. Again, I don't require that. Okay, if you want one per availability zone, so if there are 6 availability zones, again there will be 6. I want 6 single NAT gateway. Okay, so what you need to do? You need to set one NAT gateway per availability zone to false, and single NAT gateway should be set as true, and enable NAT gateway that you can anyway set. Right?
Yeah.
Got it? So single NAT gateway is true, and I don't want one per availability zone, so that I need to set it as false.
Okay.
Okay. Yeah, so this is also done, and let's look at the other configurations. Okay, so Okay. And then single NAT gateway, this is done. Okay. Knuckles and all are there. That's fine. So we don't require anything. Okay, but let me show what all other things you might require. Uh, this module expects as an input. See, these are all the resources that this module will create. Okay, these are all the resources you can see on the top, and these are all the inputs. Okay, so ASIS we have given, CIDR we have
Yeah.
given. Okay, see, create database internet gateway route in case if you are planning to deploy databases. So on the top, if you go to the this repository where we have Terraform AWS VPC, and if you go to examples, okay, and then if you go to complete examples, so you can create, okay, if you go to main.tf, you can create multiple subnets. Okay, so private subnets, public subnets, we have database subnets, elastic cache subnet, okay, intra subnet. So you can create multiple subnets. Okay, not only public and private. Okay, and depending upon the documentation, okay, so they will create internet gateway for databases, NAT gateway for the database. So you need to enable. You can see also the data type they are expecting. So if you want to create database internet gateway route, simply copy this and put it equal to true in the module in here somewhere.
Okay.
Got it?
Yeah.
And create IZW. Okay, so by default ID gateway will be created. Okay, and then so so these are all defaults and databases. So I'm looking for enable, should be if you want to add gateways for. Okay, I think some are defaults which are already true. Okay, so how do I know whether these are some are true or false is, so if you go to the complete example and if you go to the variables of these, okay, so some variables they anyways they will use, right? Okay, I think they are not using anything. Some they will, I think they will set it as defaults. Okay, so there are some tags that you can give to this VPC. Enable VPN gateway, that is already set as true. What all other things I can use? So let me see. There should be tags for the public and private subnets. That's what I'm looking for. And okay, so here map public IP on launch. Specify true to indicate that instances launched into the subnet should be assigned a public IP. Default is false. Okay, so let me make it as true. Okay, just in case if you want the public IP. Okay, clear?
Yeah. Yeah.
And
So here
then
we are not giving any name, right, for the
no,
subnets.
no, subnet names will be automatically calculated. See, subnet names also, I think. So if you look at the, oh my God, subnet results are subnet underscore name. See here, private subnet names. So if you pass it as a list of strings, then they will be taken. So you want to create? Let's do that. Okay, so let's hard code it and see. Okay, so these are the CIDR ranges. Now private subnet names. Okay, so let me hard code it here instead of variable. Okay,
Okay.
let's say private US East 1A. Okay, something like this. Okay, clear?
Yeah.
So everything is mostly configurable. Okay, and this becomes 1C. Okay, remove the last this thing, and then let's copy it. Okay, and then public subnet name. So everything is auto complete, so we also don't have to
Okay.
worry. Okay, but anyways they will use the best possible naming conventions to um, name them. Okay,
Yeah.
so we don't have to worry about the names. Okay, all I'm looking is tags, because when we talk about EKS, okay, public and private subnets will have certain tags. Okay, see, private subnet tags and public subnet tags. Okay, private subnet and tags, and also it is expecting which one? Private subnet tags, map of
Map
string.
strings.
Okay, so let me also provide those tags. Okay, somewhere. Okay, so this tag is VPC tag. Okay,
Okay.
so public subnet. See, you can also tag route table and all. Okay, a private subnet tags. So they are saying it is map, right? Okay,
Yeah.
let's say, what should we do? What should we put? Let's say, give any. Okay, let's use this simple. Okay, subnet is public. Something.
Okay.
Okay.
Yeah.
Okay, we'll talk about with what all to put um uh for the EKS. We'll see later.
Okay.
Okay, so I need to refer the, I think, documentation. Subnet is set to uh private. Okay, so let me do it right now. Anyways, we will search EKS documentation. Okay, getting started with EKS documentation. In the cluster, creating a cluster. Okay, this is through EKS CTL. Then I think node groups or maybe networking, VPC and subnet requirements here. Correct. Okay. So here what they say is, so this EKS requires some combination of public and private subnets. Okay, and also subnets should have, yeah. So if you want to deploy load balancers, right, in EKS to load balance the traffic. Okay, so the load balancer should be public. Okay, then you need to use this key and value. Okay, so
Okay.
this is for the private subnets. Okay, you need to use this key value. Okay, so let me go to the private subnets. Then let me okay, let me quote this one, and then let me set it to 1. Okay, so for the public subnets, okay, let's say you're creating a Kubernetes service of type load balancer. Okay,
Yeah.
so load balancer has to be deployed, right? Usually load balancers will be deployed in the private public subnet to get the public internet access. Correct. To be
Correct. Yeah.
accessible from public. So let's say, so there is an internal requirement for you where you want the load balancer to be internally available. Then if you put this tag when you're writing EKS Kubernetes service definition, if you put this as a label, I think it is a label or annotation. Probably it is annotation. Okay, we'll see that later. Okay, then the load balancer will be deployed inside which one?
Right. Subnet.
Private subnet. Okay, so this is internal. Okay, so what is external? It is role only ELB. Okay, so this becomes the this will be deployed in the
Public.
public subnet. Okay, okay, because we'll have the combination of public and private subnet in the EKS. Okay, that's the reason. Got it?
Okay. Yeah.
Now
Got it.
our almost the complete VPC block is ready. Okay, so if you want to add outputs, yes. So I need to add the outputs, right? Okay, so which outputs I need to add? The module outputs. Clear?
Yeah.
Okay, so till now I did not print any outputs. Okay, so using module, basically I'm creating VPC, but I'm not extracting any outputs. Okay, so output. Output, probably I would need subnet IDs. Okay, subnet, this is the CIDR range we are providing, right? But
Yeah.
I need subnet IDs. Okay, because I need to provide it to some other module as an input. Okay, so let me say private subnet, or let's say IDs, right? It will be usually a list because there are more than one subnet. So value should come from the module dot VPC, because we are actually using the module with the VPC as the local name. Okay, so module dot VPC dot Okay. So it will give you the suggestions. Otherwise, what you can do is you can go to the module documentation. Okay. So if you scroll to the top, okay, here you'll have the outputs. So if you go to the outputs, then you can search for, let's say, public subnet. Yeah. So list of IDs of public subnet. So I just have to use this. Okay. Clear?
Yeah.
Okay. And then I would need, okay, sorry, this is not public. This is private
Private.
underscore subnet. So if I need public subnet, so these are IDs. So in fact, I can also put a name that is much more meaningful. Got it? Other than
Yeah.
that, what I would require, maybe let's say that I would require the internet gateway ID. Okay. So let's say IGW, let's say ID. Okay. And then the value will be module.vpc dot probably IGWID. Okay.
Okay.
IGW. It is automatically, anyways, it is giving me the suggestion. That's it. So we are almost done with the VPC. So let me do Terraform apply auto approve. Clear everything?
Yeah. Yeah.
Okay. So use these variables as much as possible. So we have hard coded something, but anyways, this is just for the example. So it is okay for now. Okay. It says public subnets. I think I did not save that variable file. I saved it just now. I think it should be good.
Okay.
So VPC takes almost like 5 to 10 minutes. Okay. It won't be that fast. Okay. So we should wait once the process starts. Okay. I think there are no issues. Okay. It is going to take some time. Yeah. So now it is created, right? You can see the IGW Internet Gateway ID and the public and private subnets that are created. But here I'm interested in checking those details from the console. Okay. Let's go to the VPC. Okay. So now there will be two VPCs. One is the default and the other is my custom VPC. Now, if you check this custom VPC, you will see that this is not default. Okay. You can see the CIDR, you can see the resource map. Okay. In the resource map, you can see here. So this VPC has how many subnets? So we have, sorry, there are 3 availability zones and then there are 6 subnets. Okay. And then inside each availability zone, there is one public and then there is one private. Got it. It is equally distributed. And then there are 2 route tables. Okay. So one is the public route table. Okay. So which is associating public, this subnet, public subnets with the, which one? Internet gateway. And then the other one is the NAT gateway, but I'm not sure whether this is internet gateway or this is NAT gateway. What I have to do, I have to open them separately. That's it. Okay. So what is this my custom VPC? So it should be what? It should be gateway, right? You can see internet gateway. And the other one should be NAT gateway. You can see the NAT gateway. Okay. So as I already mentioned, NAT gateway gets launched in the which subnet? Public subnet. You can see in which subnet it is launched. And also whatever names that we have given, that names are only used. And then it also has a public IP address. Clear? And then internet gateway, anyways, it won't have anything as such. Okay. You can also see we also have subnets and then we have created tags for those subnets, right? So here public 1A, 1B, 1C, private 1A, 1C. If you select them and if you go to the tags, you can see our tags that we have created. Okay, see Kubernetes role ELB set to 1. Got it? Yeah. Understood now? Yeah, Vikram. How to use modules. So this is about creating VPC. We did not deploy anything. Of course, it is not required, in this example. But now, so once you deploy AWS EC2 instance, okay, now you have an option to select. Okay, so let me quickly show you that example as well. Okay. You can decide which availability zone, which subnet inside that availability zone, whether public or private. Okay, that you can decide now. If you go to browse provider, AWS, documentation, and if you search for AWS underscore instance, okay, AWS underscore instance. Okay, so we know a simple EC2 instance which will have AMI instance type tags, right? Okay, if you look at the argument references, now you can select in which availability zone, okay, whether to associate public IP or not. Okay, and then you can decide
VPC.
in which subnet VPC. No, anyway, sub VPC is not required, subnet is required. Okay, yeah, subnet. Okay,
Okay.
so what is the subnet? In this subnet you wanted to launch it, so the in-situ instance tags, user data. Okay, that's it. Okay,
Yeah.
understood now?
Yeah.
Then
I
you
got
can use those to launch, because anyways we now have the public and private subnet IDs. Also you can use AWS console to see them. Okay, so let's quickly destroy them. Okay,
Yeah.
so now everything will be destroyed.